Welcome to the KITP and to our annual Teachers Conference. As you can see, we worked hard all night to make sure the rain would stop. Can't guarantee it all day. Tomorrow's supposed to be beautiful in any case. For those of you who haven't been to Santa Barbara before, this is about as bad, well, yesterday was about as bad as it ever gets. This Teachers Conference is a little different than some of the others we've had before on subjects that are more recognizable to people as physics. Last year we did Teachers Conference on astronomy, astrophysics, studying exoplanets, and the year before we had the sea, and so on. And this year our Teachers Conference is on biology and physics, evolution of life and evolution of science. And indeed coincides with the program we have going on evolutionary aspects of viruses and microbes, and which you might think is biology. And one of the goals of this conference is to introduce a rapidly changing area of overlap, which in nature is one, but in universities and high schools is often two separate disciplines called biology and physics, although the subject of investigation, which we like to call living matter, is common. And since so much is happening in biology, many theoretical physicists like us are fascinated by the problem, its complexities, and the enormous amount of data that's available that might enable understanding of fundamental physics of living matter. So you're going to have an array of talks on this subject, and I'm sure you will all learn a lot. I intend to learn a lot. It should be a very enjoyable day. We tried to bring to this Teachers Conference new participants, as always, but not only new people, but also people from other fields, biology. And I'm just interested, before we start, and for the help to our speakers, first of all, how many of you, if you had to choose, would classify yourselves as biologists? Okay, it's not. I wouldn't say it's maybe a fifth, 20%. How many of you teach biology? Okay, so we have about a substantial number who can keep the others honest. The other question I like to get at the beginning is, how many of you have been here before? Oh my God. How many of you have never had the pleasure of being here before? Well, that's all the biologists. Huh? How many of you are not biologists and have never been here before? There are a few. Okay, half. Well, so many of you have been here before, and so I will go through the announcements rapidly, and if you haven't been here before and have a question and I'm not clear, turn to your neighbor. Parking, if any of you had parking over there in lot 10, where you're supposed to park on the 5th floor only, you can get a day permit from the pay station near the elevator for $3. Bathrooms are across the courtyard where we will be having coffee and lunch, men's and women's, and down that way there's a men's bathroom, and upstairs a woman's. All the food will be in the courtyard, which unfortunately is covered with a tent. Posters in the commons room. There are posters? No. This is the standard conference. No posters. Maybe we should have. Computer room, if you need it, is upstairs, and if you want to log on to the internet under KITP conference, you don't need a password. Okay. So our schedule is follows the usual format. We're going to have 4 talks, and in addition to the talks, lots of breaks so you can talk to us and to yourselves, and lunch, and in addition, 2 or 3 special sessions. One at the very end will be a presentation about Los Combros. A lot of you have heard about that before and visited there, but for some of you it'll be new. There will be a short discussion about the contest that you'll hear about before lunch. We'll have a description from one of last year's prize winners, and we'll discuss the ongoing contest at that time. And following that, and before lunch, we'll have our standard town hall discussion, where the speakers and I will say a few words about ongoing issues in science education at the secondary school level, but mostly we'd like to hear from you, and we have an interchange of opinions that is usually quite interesting. Last year it was mostly complaining about the severe cuts. They haven't gotten any better, but this year I hope we won't just redo that. Didn't help to complain last year. But you might in the next hour, a few hours, think of something else to say. We'll provoke you. So I'm going to start by turning over the microphone to the chair of today's session, Luca Poletti, who comes to KITP from the University of Naples, is one of the organizers of the virus and bacterial evolutionary program that's running now, and he's going to chair the first session. Luca.
Hi, so welcome you all, and try to give some ideas about why do physicists get so interested in evolution at this time. If you read the very last sentence of The Origin of Life, you'll find that Darwin makes a comparison between the endless circling of this planet around the sun according to the fixed law of gravity, and the fact that life has instead evolved endless form, most beautiful and most wonderful. And so it gives the idea that, well, in some sense, physics is boring. It just keeps on going the same way. And life is really exciting because it really introduces novelty. And it evolves in the sense that it goes on to explore always new things. We have learned in the last 150 years that physics is not so boring after all. And even the fact that the planet keeps circling around the sun is not so obvious. I mean, the theory of chaos told us that after all it can do many things even within the fixed law of gravity. But that doesn't make biology less exciting. In fact, we have learned that we can understand how the living work only if we understand, on the one hand, at the molecular level, how all this machinery is going on. So Lewontin distinguishes in biology 2 kinds of questions, the how and the why. No, the how is ultimately rooted in physics, and is the way, I would say, what are the constraints at the physical-chemical level that make the machinery work. The why can ultimately only be answered by understanding evolution. And this is the bridge between the two things, is what we strive to make. And what we have learned in the last years is that even at the level of answering why, there are patterns in evolution which really ask for a physics-like understanding. There are different patterns that arise in different, evolution is not episodical. Life asks all the time different problems, but these problems are answered more or less in similar ways, and these are the ways that we are trying to understand. So this is, I think, why a few physicists have turned to evolution, trying to understand evolution itself by the methods of physics. And one of these physicists is Boris, who is going to talk on unexpected physics in biology. So please, Boris.